Remember the insane black hole from Interstellar, the Gargantua? It's not just a cool visual effect. Quite the opposite. It's a central character in the movie, an object that bends space, time, and the entire plot. Welcome to Explained by me, and today we'll talk about the story of one of cinema's masterpieces. What makes Gargantua so special? What is its role in the movie? And the biggest question of all, could a black hole like Gargantua actually exist somewhere out there in our universe? Let's find out. So, what exactly is Gargantua? In the movie, it is a rapidly rotating, supermassive black hole, located in a distant galaxy, which can be accessed through a wormhole near Saturn. It's orbited by a system of planets, the Miller's planet, the Man's planet, and the Edmund's planet. All three of those planets could potentially be habitable. The design of Gargantua is one of the most scientifically accurate depictions of a black hole ever put on screen. Director Christopher Nolan worked alongside the Nobel Prize-winning theoretical physicist Kip Thorne to ensure it was scientifically accurate. The visual effects team then used Kip's equations to generate the final image. What they created was stunning. We see the terrifying event horizon of the Gargantua. Surrounding it is the accretion disk made out of plasma. But how does the disk wrap around the top and bottom of the black hole? That's a phenomenon called gravitational lensing. Gargantua's immense gravity is so strong that it bends the path of light from the part of the disk behind it, making it visible from the front. This was so accurate that the simulation process actually led to new scientific insights for Thorne and his team. In Interstellar, Gargantua is both the protagonist and the antagonist. It's the reason our mission exists. Its powerful gravity keeps its planets in orbit, and one of them could be humanity's new home. But if it's the hero of humanity, how can it also be a villain? The primary danger is time dilation, the consequence of Einstein's theory of relativity. The closer you get to a massive object, the slower time passes for you relative to someone far away. This is clearly shown on the Miller's planet. Orbiting so close to Gargantua, 1 hour on its surface is equivalent to 7 years back on Earth. When Cooper, Brand and Doyle spend just a few hours on the water world, 23 years pass for Romilly, who stayed in the Endurance spacecraft. This time dilation creates immense emotional tension. Cooper is racing against time to save humanity and see his children again. Every minute spent near Gargantua costs him years with his family. Insane way of keeping us on the edge. Beyond time dilation, Gargantua presents other physical dangers. The tidal force known as spaghettification would typically rip any object apart. However, the movie explains that because Gargantua is a supermassive and rotating black hole, the tidal forces at its event horizon are survivable, at least in theory. This rotation is key. A rotating black hole, also known as a Kerr black hole, drags space-time around with it in a process called frame dragging. This is what allows for the possibility of stable orbits like Miller's planet and, ultimately, what makes Cooper's journey into the black hole itself possible? Let's answer the question. How does Gargantua impact the plot of our movie? It is the hub around which the second act of the movie revolves. The crew of the Endurance must first pass through a wormhole to arrive at the destination. There, they visit the 3 potential worlds. The choice of which planet to visit first is dictated by fuel and, more importantly, by time. Their brief, disastrous trip to Miller's planet costs them decades and 1 crew member. It is the perfect example of task failed successfully. Their next stop, man's planet, leads to betrayal and another death, all under the ever-present influence of Gargantua. The climax of the story is Cooper's decision to pilot his ship, the Ranger, into Gargantua itself. He does this to shed weight from the Endurance, allowing Brown to have enough fuel to reach Edmund's planet. It's a sacrificial act, for sure, but this is where the science fiction of Interstellar takes a leap. Inside Gargantua, Cooper doesn't get crushed into a singularity. Instead, he enters the Tesseract, a five-dimensional construct created by a future, highly advanced human civilization. This Tesseract allows him to interact with gravity across time, allowing him to communicate with his daughter, Murph, in the past, through the bookshelf in her room. He sends her the data needed to solve the gravity equation, which allows humanity to escape the dying Earth. In this sense, Gargantua is not just an obstacle, but also the solution. The black hole becomes a physical manifestation of the movie's central theme, love. It can transcend the dimensions of space and time. Cooper's love for Murph is the force that guides him through the Tesseract, allowing him to communicate through objects from her room. The black hole is the medium for this communication. Now, let's answer the question, could a black hole like Gargantua actually exist in our universe? Absolutely. We have strong evidence that a similar one, Sagittarius A*, sits at the center of the Milky Way. It's millions of times the mass of our Sun, just like the Gargantua. This supports the claim said earlier. What about a planetary system orbiting a black hole? It is still possible. While the black hole and its surroundings are extreme, with intense radiation and heat from the accretion disk, it's theoretically possible for planets to exist in stable orbits. If a star system got captured by a black hole, the planets could actually end up orbiting the black hole. Habitable planets, on the other hand, would be a more difficult thing. They would need at least decent conditions and heat. The movie suggests the accretion disk, but its radiation would surely evaporate any life. So, stable orbits are possible, but habitable planets in such orbit are likely a stretch. And what about entering a black hole and surviving? This is really uncertain. According to our current understanding, anything crossing the event horizon of a black hole is destined for the singularity at its center, a point of infinite density where the laws of physics break down. The idea of a tesseract or any kind of stable structure existing inside is purely speculative. While Kip Thorne has theorized about what might happen inside a black hole, there's no evidence to support the existence of a five-dimensional space that allows time-travel communication. This part of the movie is most likely a way to resolve the plot in a satisfying way for the viewer, rather than a prediction of what would actually happen. Summarizing, the visual appearance of Gargantua and many of its properties, like mass, rotation, and gravitational effects like time dilation and lensing, are well grounded in real science. We can thank Kip Thorne for that. However, the idea of habitable planets orbiting so closely and the possibility of surviving a trip to the black hole to communicate are heavily speculative. But that's what makes Interstellar great. It takes real, difficult to comprehend science and uses it as a foundation to show us a story about love, loss, and survival. Gargantua is not only a monster, but also a test of human endurance and ultimately a bridge across time that allows humanity to save itself. It represents the terror and the beauty of the unknown universe. It shows us that the laws of physics can be both our greatest obstacle and our most powerful tool. And it leaves us wondering, what other incredible secrets are yet waiting to be discovered in the darkness between the stars? What do you think? Is Gargantua the coolest celestial object in movie history? Let me know in the comments below. Thanks for watching, and if you enjoyed the video, make sure to like and subscribe for more content. This is explained by me. See you in the next video.